Okay, so to do the virtual version of this experiment, if you open up the simulator and I've got it embedded on this page, then what I want to do is make sure I switch on my laser. And you'll notice that I'm not using the intro version here. I'm using the one that says more tools. So on the right hand side at the bottom it says you've got three versions of the simulator. I'm using the one that says more tools. Okay. Reason being, I want to be able to turn on the normal line and I want to be able to turn on my angles. So you'll see here the angles, it's going to save me the hassle of trying to take out a protractor and trying to measure it as accurately as I can. I can leave that where it is and it'll automatically measure it to 1 decimal place of an angle. So, okay, what you need to do is collect some data. I'm going to start off with the default here where I've got air as material number 1 and material number 2 is going to be glass. And I've set myself a few just random angles of incidence. With the angles, you want to make sure you have a nice spread. Okay, you don't want to go like 20, 23, 28, 30, because then all of your data is going to be bunched up in one little spot when you go to graph it. So you don't want that. So you want to spread it out as best you can, get a nice spread on your data. Okay, so I'm going to set my angle of incidence first of all to 20 degrees, bearing in mind that, there we go, that worked. 20 degrees is the angle between the laser beam and the normal here, okay? You'll also see that you have a reflected angle on the other side, but we're not really concerning ourselves with that right now, okay? And our refracted angle is down here, and that's going to be 13.2. So I've got 20.0, and my refracted angle is going to be 13.2 degrees according to my simulator. And now I'm just going to change that to 30 degrees. Almost there. Be a little bit easier for you to do this if you do it on the web version. But web version would be a lot bigger, so you wouldn't be able to see everything. Oh, got it. Okay, so I've got 30.0 exactly. And the refracted angle then according to this is 19.5 degrees. I'm just going to work with those two numbers first of all. Okay. You just continue on for your spread of data. You don't have to use the same numbers that I've got here, but you do need to have a good spread on your data, okay? So, I'm just going to use the calculator on OneNote. So the sine of 30 degrees is half. And then I'm going to calculate the sine of the angle of refraction. So the sine of 13.2 degrees equals, that's way too many figures, so I'm just going to get rid of most of them. And the sine of 19.5 degrees. Again, I've got way too much, so I'll make that a 4, rounding up. Okay, so I've got two numbers to make a start with. Now what I'm going to do, and I'll switch to a pen so you can see what I'm doing. I'm going to take the ratio of the sine of the angle of incidence divided by the sine of the angle of refraction for each set of values. Now obviously you guys are going to complete this with as many data points as you can. I'm just going to work with these just for the purpose of demonstration. So I have 0.342, that's the sine of the angle of incidence. I'll divide that by 0.228. 0.342 divided by 0.228. That works out to be exactly 1.5. And now I'll try the next one. 0.5 divided by 0.334. And it's close, 1.497. Okay, and just so as you can tell, you should be getting answers that are really, really close to whatever this number is right here. Okay, because this is the index of refraction, or the refractive index. The refractive index is defined as the ratio of sine of the angle of incidence versus the sine of the angle of refraction. So hopefully that makes sense. Once you've done that for your data, what you need to do is try your best to graph it. Okay, and I mentioned this to you, but just in case, just a reminder, the sign of a number goes from 0 up as far as 1, so you need only have on your axis between 0 and 1, and that, so you have sine of the angle of incidence on the vertical axis and sine of the angle of refraction on the horizontal axis. You plot your points. Please do that as carefully as you can. And once you've that done, you try to do your line of best fit. Okay, and your line of best fit should run through as many points as possible, but it should kind of split the difference between them all. Okay, so if those are my data points, and this is an example of a very, very bad data point, I would use x's instead of, do not do that. Okay, please, please, please do not do that. So to draw your line of best fit, you should have as many points above the line as you do below the line. So here I've got 1, 2 above the line. This one is slightly above the line. And I've got 1, 2, 3 below the line. So that's not a bad line of best fit. Now you guys, I'm sure, will get this to line up very, very straight, because if you use the simulator, then there'll be very little deviation in your data points, so they should line up pretty straight. Okay, so hopefully that makes sense to everyone. Can you all please give that a shot? Oh, sorry, last thing. Once you're done plotting it out, you then calculate the gradient or the slope of that graph, and you can do that by the rise over the run, or you can do using coordinate geometry, y2 minus y1 over x2 minus x1. Okay, so you just pick a point that's not a data point unless it's actually on the line. So if I pick this point here, and you track down its coordinates, and you pick another one, you can use 0, 0 to be your bottom one, that's fine. So you'd have x2, y2 would be this one, and x1, y1 would be this one. And you simply apply your gradient formula, and you get out the slope of the line, and that again should work out to be the refractive index of the material. So if you used glass, then you should be expecting a refractive index of around 1.5. Okay? Okay, guys, best of luck with that. And can you please have that done for the next class? Thank you so much. Bye-bye.